Hello, everyone. I'm presenting on behalf of Team 22. Today, I'll be walking you through our database project proposal for a restaurant reservation system. I'll cover what the application does, explain our ER diagram, and I'll try to go into as much detail as I can in under 5 minutes and discuss our implementation plans. Let's get started. So, the application overview. First, let me explain our application in detail. We're building a restaurant reservation system that serves two primary user groups: customers and restaurant staff. For customers, the system allows them to browse available restaurants, check open reservation time slots, and make or cancel reservations depending on the slots. When a customer books a table, the app stores all relevant information, including the restaurant name, as shown by the fields up here. Reservation date and time, number of guests, as we can see down here, number of guests, the type of occasion it is, information including the restaurant, the number of guests, and the customer's contact information. On the restaurant side, we have two types of users: employees and administrators. Employees can view table availability, update their restaurant's information, and see all upcoming reservations. Administrators ensure that all the data in the system is accurate and up to date, managing the overall integrity of the platform. Um, the core of our application revolves around four major components, as I mentioned before: restaurants, customers, tables, and reservations. As the fields in these diagram shows. So we got customer, reservation, table, and restaurant. Now, let's go into more detail about this diagram. So let me walk you through the document. We have five main entities in our system, as we saw. First, the customer entity right here stores customer information like customer ID, name, email, phone number, and password for authentication purposes, whatever it will be. Obviously, the password is not shown here. It's a JWT authentication task, so we will be adding it as we go. Then we have the restaurant entity right here. So it contains the ID of the restaurant, the name, the capacity, the cuisine type, I guess, whatever details the restaurant needs to have, the operating hours, and so these fields are here for our MVP, the minimum viable product, but there can be more fields that can be added to it. Then we have the table entity, which represents the individual tables at a restaurant with like attributes like the number of the table, the seating capacity, and availability status flag. We also have the reservation entity right here, which is very central to the system. It includes a reservation ID, the date and time of the booking, number of guests, and a status field, which can be confirmed, pending, or canceled. We may go into more detail about this as we go, but yeah, these are the three states that I can think of right now. Then we have this entity. And then we have finally the employee entity right here, or you can say the staff entity, which stores information about the employee ID, the access level, or the staff ID, I guess, and the first name and the last name, whoever the staff is. And these are the entities. Let's talk about the relationships a little bit. So between these entities, there's a makes relationship, connects customer to the reservation, so or reserves here. So makes or reserves, same, basically the same type of relationship. This is a one-to-many relationship because one customer can make multiple reservation over time, but each individual reservation belongs to only one customer. Then we have the restaurant hosts, right, or owns tables. So through a one-to-many relationship, so restaurant can have one-to-many tables. One restaurant owns multiple tables, so but each table belongs to exactly one restaurant. Then we have restaurant also receives or hosts reservation, as we can see in this year diagram, and so Another one-to-many relationship. A restaurant can have many reservations, but each reservation made at one specific restaurant. And finally, we have the staff, which is work for or works at restaurant. This is one-to-many relationship, means multiple employees can work at one restaurant, but each employee is assigned to only one restaurant. These relationships ensure data is secure and the integrity is maintained and the model is accurate. And then I'll talk about the implementation plans a little bit. So we'll be using PostgreSQL as our primary database management system, which is required by the assignment. For the application development itself, we've chosen to use the MERN stack, which stands for MongoDB, Express.js, React, and Node.js, though our primary database in this case will be PostgreSQL and not MongoDB, which will connect to using the PG library for Node.js. Our architecture will follow a three-tier design, as we can see here. The presentation layer will be built with React for now. Creating an interactive and responsive user interface will be so one member's responsibility who knows React, I guess. And then the application layer will be written in Express.js. And we are going for a RESTful API that handles all the business logic and whatever database operations we're going to be performing. And the data layer will be PostgreSQL database, as I mentioned, implementing the schema from our ER diagram above. For security and user management, as I mentioned before, we will be implementing a JWT-based authentication for customers as well as the staff members to be able to log in and sign in into the system. Key features will include real-time table availability checking, reservation management, dashboards for restaurant staff, and an intuitive booking interface for customers. Our development timeline is structured in phases. So right now we have first we'll implement the database schema in the PostgreSQL, then we'll develop the backend API with all necessary endpoints, and finally we'll build out the React front end itself. And we'll conduct thorough integration testing to ensure everything works together correctly. Okay, so that's it for the implementation plans. I've covered the ER diagram and I've covered the basic overview and application requirements. To wrap up, a restaurant reservation system will provide a database-driven solution that benefits both customers looking to reserve tables and restaurants managing their reservations. Yeah, that's it. Thank you for your time, and I'm happy to answer any other questions.